Hey guys, been here. Previously we did some different video about hexagon patterns. Today I'm going to do another one this time. And if you look at this, I'm going to use the hexagon pattern here to create this perfect hexagon pattern. Okay, so let's do it. So first I'm going to create a mass, and I'll draw a reference line and create a face. Okay, so this is it, and then select this face, divide the surface, and in this grid change it to fixed distance, for example 1 meter, and this one fixed distance as well, 1 meter. So you can see in if it's a rectangular pattern, that's fine. Oh, sorry, square pattern. If you change it to the hexagon pattern here, and you will see this is actually not perfect hexagon. So if I turn the surface on, you will see the edge, they are not same. So for example, this one equals 1 meter, and this one will be 1414 something, which is square root of 2 times this length. So what we need to do, so I'll quickly do a sketch. So what we need to do is we need to adjust this pattern. So in this in the surface pattern, curtain panel pattern base family, there will be 6 points here. So what we need to do is we need to extend these two. So extend this edge to about here and reduce this to about here. So once you, so we will have another 2 points here, 1 point here. So and connect these, and same on this side. You will have another like this. So like this. So eventually you will have all these perfect hexagon shape. Okay, so now hang on, let me just close this. Let's create a new family, curtain panel pattern based family, and then select this pattern grid, change it to hexagon. So now you will see those 6 points I just mentioned. So what we need is we need another point about here, another point here, a point here, a point here, another point here, and another point here. Okay, so and then we need to work out how much we need to offset that point. So first let's create some points. So draw, place point, draw work plane, set point, set work plane, pick this work plane, place it on here. So and then drag this point, move it this way. Another one, work plane, place it, drag it, drag it, not this one, drag it, yep, this one. Another one, place it here and move it here. So another point here and move it. Another one here and move it. This one needs to go this way. So another one, place it here and move it to here. So now we need to create a maybe 1 parameter. So I'll call it actually before that I'm just going to go back here, and I'll I'll try to do some simple calculation first. Okay, so let's do a screenshot first, and I'll draw this shape. So these are the original 6 point adaptive point in that curtain panel base family, and then we need to create another one here. And this is too small. That's fine. I'll try to make it clear. So what we're going to do is we need to create new reference line through these points. Okay, and then we need to calculate. So first, let's say this one. So this will be one of the either U or V grid. So let's call it X. So let's call this X, and then let's call this Y. So same, either U or V grid. They will be different. Okay, so X, Y, and then let's call this offset. So this one, so the offset, this point from this, let's call this Z. Okay, same, this one will be Z as well, right? So first, and also of course this one, Z, and something else about hexagon, perfect hexagon. If so, see here, we know that this edge equals this edge for a perfect hexagon, right? And so this one, x plus 2 times z equals this one, this edge. And this edge, so I'm going to draw this a triangle shape, okay? And this will be 90 degrees. And in a perfect hexagon, this angle, so I'll just draw a big one here. This angle, which is this one, will be 60 degrees, which means if this edge, so which is this one, will equals 2 times this one. Okay, so if this is if this is 100, this will be 200. Okay, so now this is 2 times this one, but what's this one? This one is this x minus this one is z, and also this one is z as well. So this one equals x minus 2 times z. Okay, and then because this one equals 2 times of this one, and then go back to this formula, it will be x minus 2 times the bracket times 2. Okay, so x plus 2z equals 2x minus 4z, and if I move x to here, x equals move negative 4z here, equals 6z. So d equals x divided by 6. X divided by 6. So the offset, of this point from this point is 1/6 of x. Okay, so let's go back to this family. So now we can create a parameter. So create a z instance OK, and OK. So this one, oh hang on, this one negative. So I'll call it Z negative. Okay, Z negative, and I'll create this one as Z, and then go to family types. Z negative equals negative Z, and also this one, which is negative, I'll link it to Z negative. This one link to Z, and this one link to positive Z, and this one link to negative. So now we just need to get X. So X, we need a reporting parameter. So set work plan, pick this work plan of this reference line, and DI. Make sure you pick the point. Okay, so select this dimension, create a new parameter. I'll call it X, instance reporting parameter, and OK. So now go to family types. Z equals X divided by 6. Apply. OK. So now we can select this point, create a spline. I'll temporarily hide these reference lines. 1, 2, spline, 1, 2, spline, 1. Oh, sorry, wrong one. Control V. This one and this one. 1, 2, and 1, 2. So now we can select all the spline and convert them to into reference lines. So now that's part of the drop down, but we still need to adjust. So you can see the edge are the same, but the angle is still not yet it's not yet perfect, because the angle is, so for example, this one is not 120 degrees, this one's not 120 degrees. So I'll create a face for now. I'll create a face, and let's work out the relation between, we just need to work out a relation between these two grids. So currently they are the same, X equals Y. So we just need to work out what dimension we need. So to make it easier, I'll just use 1 meter, 1 meter, so it's easier, a little bit easier. Okay, so now we just need to, I'll just do a new screenshot of this. Okay, so now we need to do some more work. So now we know this is V, which is 6 X divided by 6, and then we just need to work out this. So which is this one? Okay, so either U or V, different to this 1 meter one, so which is X, call it Y, and we just need to work out the Y. If I draw a triangle shape here with the 90 degree here, so this is Y, right? And we know pretty much everything here. We know that this is I'll use this one, okay? I'll use this one. This one is X minus 2 times Z, right? And because this is, if this is a perfect hexagon, this angle will be 60 degree. Okay, so then tangent or cotangent, then we know that Y equals X, this one, times square root of 3. Okay, so and then of course we need to put the swap the D to 6 X divided by 6. So if I swap this to X divided by 6, so times 2 becomes 3. So X minus 3 times X divided by 3 equals 3 X. okay, and then times square root of 3, so which means y equals square 3 to square root of 3 times x. So this is the relation between these two grids. So u, either u or v or v or u, and then that's the relation. So now let's just load this one. So because we can't control the u and v here, u and u horizontal spacing and the vertical spacing here in this family, we need to control it in this mass. So let's load this into this mass and select it. I'll just turn off the surface. So now select this one and change it to the one we created, so that, which is this one on the hexagon, and you will see it looks better but still not perfect. So if I turn on the surface or not turn on the pattern, you will see that's the original pattern, and then this is the pattern adjust pattern. Okay, so now if you select this face, so you will see fixed distance. Let's try to increase this. We just need to figure out which one's x, which one's y. So if I type 11, is it better? No, not. So which means this one's x. So because this one needs to be smaller, right? So now let's select this face and then I'll create a x parameter. So instance or type should be the same. I'll use instance. Okay, and then for this one, I'll create a y parameter instance. Okay, and so if I go to here, y equals this formula, y equals 2 times square root of 3 divided by 3 times x. So 2 times sqrt bracket 3 divided by 3 times x. So apply, and you will see they are now perfect. So if I draw some line here, so you will see 1200, and this way 1200, 1200, 1200. Okay, so but one more thing, from and there's nowhere we can find the 1200. Maybe we can just build a parameter to calculate it for us. So first, let's have a look at this one. So how do we calculate it? So the edge. Okay, so the edge is x plus 2 times d, which is x to z is 2 times the 6, x becomes 3, so 3 for x. So this will be the edge length. Okay, so let's do it. So we just need to create a new length parameter. I'll call it maybe edge length. Okay, so instance, okay, and then for the formula, just type in 4 divided by 3 times x. So 1200, right? Apply. Okay, so now if you click on this family, where's my parameter? Is it here? No. Maybe I should. Oh, sorry, it's not here. You can just go here. So, see, now it will tell you. So if I change the, for example, x, change it to 100, so y become bigger, and the edge will become bigger as well. But you can also do it this way. So instead of change x, y, because most of the time I don't really need to know what x, y is. I only need to know what the edge length is. So you can type in here. So for example, type in 600. So it will automatically calculate what X need to be, what Y need to be. So this one, so 600. So imagine you have some carpet tile, 600 maybe, and then you can just type it 6, and then it will work out what X need to be, what Y need to be. Okay, so that's it. And another good thing about this is you can create a material parameter. So for example, material parameter, instance parameter, and then it's much easier. So now you can just create a face and place this pattern, and then you can instantly have all the hexagon carpet tile. And of course you can use Dynamo to randomize it, or just manually change the color, something like that. Okay, so I'll upload this family for you, this mask for you, so you can have a look if you want to. Okay, so thank you. Have a good night and maybe good morning. See you next time. Bye.